All right. This is your guys' help for the review worksheet, okay? Since some of you guys won't get to ask questions if you didn't start it. All right. So number 1 says if 78 is divided into 3 parts of an equal ratio of 3, 5, and 7. And my whole thing was 78, okay? What is the sum of the smallest and the largest part? Well, my smallest and my largest is 3 and 7, okay? So that's what I want to find. But I need to figure out what is the what is my ratios divided into. Okay, so 78 equals 3x plus 5x plus 7x, right? Or 15x, okay, equals 78. Then x equals 78/15. Now the question said find the sum. 3 over 78 over 15 of my smallest, which is this numbers, plus my largest, which is 7 over 78/15. Okay, and that's my answer. All right, and when you actually do that, it comes out to 152. So you got 152, you understand extended ratios, okay? A radio antenna that is 100 meters tall casts an 80-meter shadow. At the same time, a nearby telephone pole casts a 16-meter shadow. Find the height of the telephone pole. So I have one. My radio tower is 100 tall, 80 shadow. That's a right angle. Oop, ignore that part. That's a right angle, okay? Also the angle that the sun's coming, which comes in from here, and then by alternate interiors, we put it right there, okay? Then I have my next line, right? Which said my height is what I'm trying to find, and then it's a 16-meter shower. Now I just need to set up a proportion, okay? You can do it several different ways. One is little height over big height. Little height over big height, which is h over 100, equals little length, little shadow over big shadow. So 16 over 80, okay? Cross multiplies those, and you get h equals 20, okay? H equals 20. I put my setup on the wrong sheet, so I got to jump around. So I'll let you guys look at, there's that one for another minute, if you're wondering what to do for 2. There is what we did on number 1, okay? Now I'm going to jump over to number 3. All right, number 3 gave you this triangle right here, okay? It said find x. You got to look at what you were given. I was given a couple lengths, okay? I was also given these lines right here, which means that I have an angle bisector. So I probably want to use the triangle angle bisector theorem, okay? Which says that there's proportional relationship with how this line cuts these segments to the legs, right? So, and it gave you the whole thing was 16, okay? So I know this part, right, is 16 minus 6.4. And I'm just going to put that in my proportion instead of actually calculating it out. You can calculate it out, okay? So my leg that touches x is my 16 minus 6.4. So I have 16 minus 6.4. I'm going to put that over x, okay, equals, if I did a side length on top of a leg, I better do a side length on top again, 8, and then over my other segment, which is 6.4, okay? And when you multiply those out, okay, you should get 6.4 times, let's see, what is 16 minus 6.4? We take away the 10, so we're going to be at 9.6, okay? 6.4 times 9.6 equals 8x. All right, equals 8x. You should get x equals, let's see, where do we get x equals 12? All right. Do we got any questions there? If you do, you need to go look at section 7.4. Okay. That was number 3. We're going to go to number 4. Sorry, I copied these down kind of weird because they didn't bring a worksheet home. So, number 4 gave you this, and it gave me another angle bisector because it told us that CD is the angle bisector of angle BCA. All right. So then I want to use the triangle angle bisector theorem, and we're trying to find the length of AD. So that becomes my new variable. You can call it X, you can call it W. All right. And I'm going to set up my proportion a little bit different than I did last time. So let's go X over 5. Using the triangle angle bisector theorem. Okay. So I went this segment over that segment. I better go this leg corresponding to that segment, touching that segment, which is 8 over 6. And you get 6x equals 40. Okay. And then you get x equals 20/3. All right. Let's look at number 5, because number 5 can be a little bit tricky. What number 5 says is one side of a triangle is 4 centimeters shorter than a second side. The ray bisecting the triangle, so I drew the ray, okay, and it's an angle bisector, is the angle formed by these sides divides the opposite sides into 4 centimeters and 6 centimeters, 4 and 6, okay? One side of these legs is 4 centimeters smaller. What's important is that we put the biggest side corresponding with this 6. My biggest side is x. My shorter side is x minus 4. Okay. Now when I set up using my triangle proportionality theorem, 4 over 6, okay, 4 over 6 equals x minus 4 over x. Cross multiply, 4x equals 6 times x minus 4. 4x equals 6x minus 24. 2x equals 24. X equals 12. Give you guys a second to look at that work. Right? Triangle angle bisector theorem. Probably going to be asked some questions on it on the test. And we're going to move over here where we have to use the triangle angle bisector theorem again. Okay, this is number 6. All right, what number 6 said was it gave you this length, right, of 30. It gave you that it was an angle bisector. It also told you that this length right here is 24. All right, and then it gave you what these were on the coordinate plane. So you need to figure out how far is it from -3 to 5 on the x-axis. So you could do the distance formula. My y's aren't changing, so I'm going to ignore them. I know that it's going to take 8, okay, whether I do the distance formula or not, or just reason it out, because I know it's going to be 3 to 0 and then 5 to 5. So I know this entire distance right here is 8. And what we're trying to find is this distance right here. Well, this is a triangle angle bisector theorem again, because I have an angle bisector. I have 2 legs and 2 segments. Okay, so my segment of, and let's just call this one W for fun. Let's go W. Actually, let's call it QR, because that's the side we're finding. So we're going to go QR. Okay, if I put QR on the top, I can either put 30 on the bottom, or I can put 8 on the bottom. Let's put 8 on the bottom. So I'm going segment over segment. I have to line up the legs now, so 30 over 24. All right. You can multiply or you can simplify. I'm going to multiply because I know that 8 times 30 over 24 is going to simplify really nicely. And the 8's going to be gone. And then my 3 that was left is going to be gone. And I'm just going to get 10. Okay. So I'm going to get QR equals 10. Then it wants you to find the coordinates. Okay. Well, QR is on the 0. Okay. And it's 10 away from -3, so then my point is -13, or it's on the x-axis, -13, 0. All right, that was number 6. Let's look at number 7. All right, and number 7, okay? Ignore the work from number 3 up above. Okay, so number 7, this is what it gave you. It gave these lines are parallel. It gave you an angle bisector, and then it gave you these measurements. All right, and then we need to find some distances. So I'm going to find this one first. I have an angle bisector. I'm going to use the triangle angle bisector theorem, which should say that 6 over 21, so that segment over that leg, the entire leg, is equal to, I'm going to try to move this into light for you guys. Oh, I flipped this around on you. 6 over 21, all right, so that one over that is equal to x over 28. X over 28, okay? And then when I cross multiply that, I should get x equals 8. I'm going to stop doing the actual math of these because you guys know how to use math, or just do the cross multiplication, okay? 28 times 6 divided by 21 should give me 8. All right, then let's see, which other ones did we have to find? We had to find QS. Should I go back to my drawing? This is QS right here, right? Well, and then we had to find that one as well. So we're going to call that X, let's call this Z, and let's call this Y. All right, and we had to find RS and QS. So QS, we're looking at parallel lines, all right? Can I use the triangle proportionality theorem? No, because those are my parallel lines. So let's look at Y really quick, the RS value. I can use triangle proportionality theorem on that one, but I'm missing a value. Oh, I know what it is, okay? I know what that is. So I found 8 right here, right? Okay, so 6 over 8 should be equal to my distance on the top, which is Y, and then my distance from there to there is Y minus 20, or 21 minus Y. Okay, because I know the whole side's 21. So this is the triangle proportionality theorem right here. And when I do this algebra, and yes, it's a little bit tougher, you're going to get Y equals 9. Y equals 9, okay? Then, now that I know Y equals 9, okay, I can do a couple things. I can go back up here to my triangle, all right? And now that I know either this big side length, which is 14, which is what I'm going to choose to use, okay? So 6 plus 8 is 14. So 6 over 14, so that entire length right there, my PR, and my RQ over the top of it, or RQ over PR, has to be equal to my QS over my PT, okay? So my PT is 28, and my QS is my Z. And when you cross multiply that one, Z equals, what did Z equal? Z equals 12, okay? So there's a couple different ways you could have done them. Triangle proportionality theorem, triangle angle bisector theorem, or just doing a regular ratio between the big triangle and the littler triangles, okay? And of course knew that my triangles are similar because these were parallel lines. So I have corresponding angles and a reflexive angle, all right? Number 8, okay,